There's your question number 4. Please prove that they are similar and then find x and find y for me. I'm also going to find the question from last year's grade 9 final. You can also work through that one today or tomorrow. Here's your proof. Please ask if you think you did something different. Yes. PQ, the side PQ. PQ equals to ST. But we don't know it's not equal. Are you saying they're equal because of this arrow? The arrow means they are parallel. For it to be equal, it has to have a straight line, not an arrow. That indicates equal. The arrow means parallel, which means alternate, corresponding, or co-interior can be used. But it doesn't say anything about sides being equal. But we can also see that they aren't equal. This length is 10, that length is 100. So those arrows only tell us that they are parallel. Any other questions? Okay, you should be proving your x and y, finding those lengths. Okay, that's enough time. So I substituted in what I knew. Now I'm solving for x and y. Doesn't have to be in alphabetical order, so I did y first. You'll also see here that I decided I can simplify 10 over 100. It's still the same fraction, it's still equivalent, it's just a smaller number. So what I did was I'd take 10 divided by itself into 100, and that way I could immediately say that y would be 40 by cross multiplying. In my second one here, I haven't done it, so it doesn't, you can decide which you prefer, but for instance, now I'm going to have 20 times 10 is 200, 100 times x is 100x, dividing both sides by 100, x is equal to 2. So if you can simplify the fraction, you are allowed to. But that doesn't mean that you have to. Okay, our next one, just mark that quickly. Remember to draw it first. The three of you are really starting to annoy me. The whole thing on the board. So I'm going to have to make it a bit smaller for that. Can you still see? I'm going to do that. Okay, our fifth one. I'll move that back. And let's freeze it. Is anyone else still busy from the board? Okay, it's fine. I'll just draw next one while I wait for you. Omega, you done? What are you so busy with?
No, I messed up the whole thing.
Okay, is there anyone else other than Dominique busy on the board? Okay, our next example, I'll also zoom in a little bit. Please prove that they are similar and find x and y. F3G YZ. Thanks, Dominique. There are the two triangles if you were stuck. FGV and FZE. Okay, our proof. F is common, they both share this angle here. So my reason is that they are common. But then when I name my other triangles that I'm going to use, I must use 3 letters. There is no other option, else it is not clear which angle you are referring to. So since F has only one option, you can use 1 letter for F. But here, if you talk about G, you could be referring to the whole angle, which is not what we want. We only want this portion, and therefore, I need you to use 3 letters. So FGV is equal to FZE. I've used corresponding angles are equal, where GV is parallel to ZE. And then you could have used third angle in triangle, or you could have used the other corresponding angle to get that third angle there. Therefore, they are similar, and I've proven using angle, angle, angle. And lastly, I can state which sides would be in proportion, and what they would be is FG over FZ is equal to GV over ZE, and FV is equal to, E is equal to FV over FE, sorry. So that's just the proof part. That would be 1 question, 3 to 4 marks. And then I'm going to prove the side lengths, or find the side lengths by substituting in what I know. And you have to be careful. When I'm talking about FG, that's quite clear what I'm talking about. Okay, here's my FG. But FZ goes from F through to Z. So what is that length of FZ? 3 plus y, not 3 times y, 3 plus y. Nice, Alex. And then we also know that FV is part of it, which is 5. But we also have FE, which would be what? 5 plus x. And that is exactly what we are going to substitute when we substitute it in to our fractions at the bottom. I know it's a bit small, but some of you are still writing. So I would say 3 over 3 plus y, and 5 over 5 plus x. And then obviously our 7 over 49. Jessica, why do you look so confused? You don't know how to do the calculus. Okay, well, I'll go through it step for step now. But you now substitute those values. Okay. And the reason why I can say they are all equal is because I know that they are similar. Okay, I'm going to focus in on the fractions. If you need the other stuff, I'll show it afterwards. Okay, so I need to find a way to solve for one variable at a time. Now I'm only going to use these two, and I'm going to solve for y first. It doesn't really matter. And just like I was doing before, I'm going to cross multiply. But now it's not as clear. But what we do need to consider is that this denominator cannot be split up. I need to keep it together, and therefore I have bracketed it as one entity. When I cross multiply, it's going to be the bracket times the 7, and it's going to be the 14 times the 3. Now I can leave it as 7 and 14, or I could simplify it to what? 1 over 2. I'm trying to not use my calculator, so I'm going to simplify to 1 over 2. But the cross multiplication still happens. I'm still going to have 1 times 3 plus y. I'm still going to have 2 times 3. 1 goes into my bracket to both values. 1 times 3 is 3. 1 times y is y. 2 times 3 is 6. I have 3 on this side going over becomes minus. 6 minus 3 is just equal to 3. Because you multiplied with your 3 times y, didn't you?
I just said 3y over 3, and then...
Exactly, you got 3y, which is 3 times y. It must be 3 plus y.
I'm going to still look at right answer.
That's probably coincidence.
So I said 3y over 3, and then using...
Oh, you're doing a big triangle, then a small triangle.
Yeah.
Okay, that's fine. Do it over.
and x.
Okay. That's just coincidence. Two coincidences equal the same answer. It has to be plus, we're not multiplying. Let's look at my x, and I'll do it on over here. And I won't simplify. So let's use the big numbers, because I'm sure some of you did use the big numbers. So I know there's going to be 7 over 14 equals to 5 over 5 plus x. If you did a multiplication and you happened to get the same answer, you will not get the marks. Cross multiplying. Since I have two values here, I'm going to protect it so that it is 7 times the bracket. 5 times 14 should be 70. Multiplying into my bracket. 7 times 5 is 35. 7 times x is 7x. I have positive 35, take it over becomes negative 35. Seven x will be equal to 35, and now I need to divide both sides by 7. $35 divided by 7 is equal to 5. So those are the two things to note. It is the variable plus the side, and when we cross multiply, you must protect if there's more than one term. Yes, Alex?
No, I wrote down the wrong number at the beginning, so I thought it was 49 and not 14. So I was getting so confused. Then I realized.
No, you didn't write the wrong number. I wrote the wrong number. I wrote 14, not 49. No, it's me. But why did it take two sums later for someone to say something? So you know that I make mistakes too. Not that much. You need to trust yourselves. Okay, let me just redo it. Okay, from that point. I'm just going to do it from that point. So we have fg, which is definitely 3. Fz is definitely 3 plus y. Gv is 7. Ze is 49. Fv is 5. And Fe is definitely 5 plus x. Okay, now I'm going to use my first two first. And I'm going to simplify it as 1 over 7. Cross multiplying, protecting when I cross multiply. 7 times 3 is 21. 1 times 3 plus y. 1 times 3 is 3. 1 times y is y. So when I take my 3 over, it's going to be 21 minus 3, which is 18. Yes.
Ma'am, I got 3. It's a 14, Hannah. I didn't use 14.
But remember, you had 3y, not 3 plus y.
But I also, with my fraction, yours is fg over fz, mine's fz over fz.
It doesn't matter, it will get the same answer.
And then I said, 1 times 3 plus y equals 2 times 3. And I give you 3 plus y equals 6.
But where do you get the 3 from if it's 49? Like Jessica said. I will do the second one without simplifying, because the simplifying seems to be confusing you guys. 7 over 49 is equal to 5 over 5 plus x. Immediately I'm going to protect it, because I know that it has to be multiplied as a whole unit. So I'm going to cross multiply, which is 7 times the bracket, and cross multiply 49 times 5, 245.
Ma'am, I still did not get 18.
I'll be with you now, Hannah.
I got like 18 times 7.
Multiplying into the bracket, 7 times 5 is 35. 7 times x is 7x is equal to 245. Pardon? Yes, it will.
I got x right. I don't know what x is y.
So 245 minus 35 when it goes over is 210. Dividing by both sides by 7, x is equal to 230. let's just see which one's wrong.
Small y, the top one.
Take it back, is that what you were given? 3
Yeah.
over y times 721, because your 7 times y is? Okay, what is so funny? It's been this whole lesson now. Now I want to know. Nathan? I'm waiting. What is so funny that you have been laughing for the past half an hour? Let's do our next one. Just hold on a second. Yes. Yes, you may. Here's our next one. Was anyone busy with the last one? I can give you the page. Were you so busy?
No.
You want to ask? Yes?
What is AOG? Nothing needed.
There's nothing there. I don't need it. I'm not asking about it. There's nothing there. Hold on. Yes?
Then how do you put them in Gmod? You add the 603.
Don't just wait. Try to go as far as you can. So I have G, which is common. They both share G. And then I get given parallel lines, which means alternate, corresponding, and co-interior might be useful. Hold on. Yep. No. It can't be 0, it has to be a value. And yes, you do need it, but remember, if this was a geometry question, I can use all geometry things that I know. What kind of triangle have I been given? Okay. With the length of sides means? Okay, let's look at that proof. Poor thing. Okay, we'll look again tomorrow, but you are going to need Pythagoras to find TG, and then you can use that to find X. We'll continue tomorrow. We're also probably going to start congruency tomorrow, because this went a lot faster than Mrs. Piper anticipated.